Alright, this video is going to go over the law of conservation of mass. So what I want you to look at in this picture is that we're starting with a couple of things over on this picture on the left, CaCl2 and Na2SO4, and we're ending up with two different things on the right, CaSO4 and NaCl. But the one thing that's staying the same is that the mass of what we're starting with is the same as the mass that we're ending with. And this is because of the law of conservation of mass. The law of conservation of mass states that the mass is neither created nor destroyed during a chemical reaction. We're going to rearrange some things, but we're going to end up with the same amount of stuff that we started with. Okay? So if we're trying to apply this law of conservation of mass, the mass of your reactants is going to equal the mass of your products. And our reactants is what we start with, just so you know, because I'm going to use these terms, and the products are what we end up with. Okay? So, in this first question it says, a student heats up HGO, which is mercury oxide, causing a reaction that produces HgO2. If we start with 110.3 grams of HGO, how much Hg and O2 are produced? Well, we're going to make 110.3 grams of Hg and O2 combined. If we measured 73.6 grams of mercury, how much O2 was produced? Well, we're going to take our 110.3 and subtract 73.6. So let me write this down. 110.3 minus 73.6, and that's going to give us 36.7 grams of O2. Okay? And that's all we have to do for the law of conservation of mass. So when you look at question number 3 here, let me just slide this up. It says a laboratory process designed to separate water into hydrogen and oxygen gas. A student collected 10 grams of hydrogen. So let me write that down here. This is 10 grams of hydrogen. And they collected 79.4 grams of oxygen. How much water was originally involved? So we treat this kind of like a math problem. We're trying to find out how much water, that's our unknown, our x. And we know that 10 grams and 79.4 grams were produced. So if we add these together, we're going to find out how much water we started with. So 89.4 grams of H2O is how much water we started with. Looking at this next question, a student carefully placed 15.6 grams of sodium in a reactor, supplied with an excess quantity of chlorine gas. When the reaction is complete, the student obtained 39.7 grams of sodium chloride. That is NaCl. Calculate how many grams of chlorine gas reacted. How many grams of sodium reacted? So we have 15.6 grams of sodium. We're trying to find out how much chlorine reacted, and that's going to equal how much sodium chloride was produced, so 39.7. So in order to get our x by itself, we're just going to subtract 39.7 minus 15.6 to equal 24.1 grams of Cl2. And that would be our answer, if I'm doing my mental math correctly. And looking at our last question, the student performed the following chemical reaction. Joe started with 13.7 grams of AgNO3. So we have 13.7 grams of AgNO3. And he started with 12.1 grams of NaCl. He was able to measure the AgCl that was produced and found the mass to be 9.2. So our arrow is going to be our equal sign, and we made 9.2 grams of AgCl. How much NaNO3 was produced in this reaction? So that is our unknown. We're going to treat it like a math problem, so we're going to add our 13.7 plus our 12.1 first, so that would be 25.8 on the left side, is equal to 9.2 plus x. So we'll subtract 9.2 from this side to find out how much of the NaNO3 we have, and our x is going to equal 16.6 grams of NaNO3. And that would be our answer. So that's the law of conservation of mass. the mass that we start with has to equal the mass that we end with. So if you have any questions about that, go ahead and just let me know.